5.2, we have a couple of questions about how you get to school, the speed you go, the distance you travel. All of this to demonstrate that we have a very particular understanding of transportation in 2013. And I want you to understand how we think, because it is very different from how people thought about transportation 200 years ago, about the speed they travel, how far they travel. We're going to start by talking about canals and rivers. One big difference between a canal and a river is a canal is man-made. There's also no current. One really important canal links Liverpool and Manchester in Great Britain. Manchester was a fairly new city, which I'll talk about in a second, and they are interested in being connected to Liverpool because Liverpool is a port city. It is a natural harbor so that the manufacturers in Manchester, the business owners of Manchester, can get their products easily and quickly to other parts of the world to sell it. In canals, because there is no current, the boats that would travel down them would have to be pulled, usually by a horse or a mule. And that's okay, because the horse or mule is attached to the boat by a harness, and water is very smooth. So you can put a great deal of cargo on these boats, and it's much easier to transport that rather than being in a horse and carriage and going over rocky terrain. So this had been used for a number of years, decades. But then there is the steam engine. James Watt is a Scotsman, meaning he is from Great Britain, and he comes up with the first really usable steam engine. There had been a number of attempts before James Watt, but 1765 is when his steam engine really takes off. To give you an idea of how a steam engine works, this is the basic mechanism. If you look on the right, there is a boiler, a fire that is fueled by coal. That water boils, and that steam from the water will go into a chamber. The pressure of the steam pushes up a piston. Now this is like when you take a shower and it gets all steamy inside your bathroom, and you open up the bathroom and all of a sudden the steam rushes out. So we have a chamber filled with steam, and then there's another chamber filled with cold water. You see in the middle at the bottom. That cold water is sprayed into the chamber with all of the steam, and the steam disappears and the piston falls. So the lever you see, the burgundy lever you see up at the top, will go up and down as this process of steam filling up a chamber and then disappearing with the cold water. Steam filling up a chamber, disappearing with cold water. That pressure and that process creates a source of energy. You can connect that movement to something like a water wheel, propelling something, which eventually will happen from Robert Fulton. He is an American, but he's the first one to really effectively connect a steam engine to a water wheel on a boat. So here you go. You see the water wheel on the side. It is connected inside to a steam engine, so that process of steam pressure created and eliminated. You can see the black smoke from the coal fire. This is important to keep in mind. We very often think of pollution and health. That wasn't a concern 200 years ago. So now with a steamboat, boats can quickly and effectively transport goods down canals, down rivers, up rivers going against the current. There's many possibilities for trade and travel. Something else that is new is rail. And I say rail, not trains, because we have the engine capability. The rails are sort of what's the important part. Rails were originally used in coal mines because it was getting very difficult to carry bags of coal or to try and push a cart over rocky terrain. So rails were created to create a standardized, smooth track. People look at this and say, well, could it be used for something other than coal mines? Could it be used to get produce from one place to another, to get manufactured goods from the factory to the harbor? So as they start thinking about this, there's going to be this process of, similar to the triangle trade, that they're going to need more coal to power those steam engines. If there are more steam engines, people are able to travel farther, make their produce or their products travel farther. They will need more rails, therefore they need more iron. This is a process that's getting bigger and bigger and bigger. The first train, as we would recognize it, is in 1829, created by a British man, George Stephenson. He calls his train the Rocket, and it goes an astounding 29 miles an hour. Now, to us, we regularly go 29 miles an hour just pulling out of our driveways. 29, 30 miles an hour 200 years ago is incredible. The fastest you could go, you could run, but running consistently, even at marathon pace, is 8, 9 miles an hour, maybe 10 miles an hour, but you can't keep that up for long. So you would have to walk. You could take a horse and cart, or you could ride on horseback. A horseback consistently can ride about 18, 19 miles an hour. So this is the fastest that people have been able to travel before. This is what the Rocket looked like, a very small, basic train. You see the cream smokestack and the coal smoke at the top. You see the steam being expelled from the black piston, that process of the steam building up and going down, the pressure going up and down. And that up and down motion connects to the wheels and propels it forward. If you look at the clip, if you're in Canvas, from Return to Cranford, it shows, and we watched this in class, it shows these little old ladies the first time they ride a train. It's sort of funny, but only because we're looking at it from a 21st century perspective. Trains and the ability to travel this fast on a machine that is loud and smoky and large was potentially terrifying. But it works. Within 20 years, by 1850, there are 6,000 miles of train tracks in Great Britain alone. So there's all sorts of possibilities with that. And you got to think, before trains, travel took a long time to get from London to about Exmouth down on the southern coast, or Portsmouth or Exmouth. That would take about a week in a horse and carriage. In a train, it just takes hours, 6, 7, 8 hours. Today, in a car, 4. So the possibilities are huge for trade, for individual transportation. All of these farmers' children who don't have work at the farms anymore because farmers are working more efficiently, they now can travel to other locations to find work. Now, this isn't just in Great Britain. Great Britain was first. So again, I want to look at this relationship, like the triangle trade and mercantilism, where it gets bigger and bigger and bigger, between coal, steam, and iron. I would say that the coal comes first, because you need to burn the coal. Coal burns hotter than wood. It burns a hotter temperature and more consistently, so that's why it is so desired for this. You need to burn the coal to boil the water to create the steam. So now you have a working steam engine to go places, but a steam engine can't go places unless it has the rails. So you need more iron. To create more iron, to create more rails, to build more machines, which means you need more coal to power those machines. So it is this clockwise triangle, again, that gets bigger and bigger and bigger. This all is happening on Great Britain. Eventually, the Industrial Revolution will happen on the continent as well, but it takes a few decades. It takes until after Napoleon, after the revolutions, for some sort of stability. And I want you to know these places now, because the fact that they industrialized first on the continent will play a big role in what happens second semester. First, there is Belgium, and then France, specifically the territory of Alsace-Lorraine, and Western Germany. And if you think of it, that territory in Western Germany that has the diagonal lines, Belgium and Alsace-Lorraine, they're all right next door to each other. That is significant because they all have similar natural resources to what Great Britain has as well. So this will be the territory on the continent that will industrialize before everyone else. It's also nice that it's fairly centrally located. All of this leads to a process of urbanization, meaning that moving away from the farms, moving away from rural societies into city-based societies or urban societies. This is significant for a number of reasons. One is the agricultural system has been in place for millennia. This is a recent thing, the idea of big cities and lots of people living in it. It's only a couple hundred years old. Some of these cities are old cities, like London. London was established by the Romans. But some cities are created overnight simply because they're in the right place at the right time. Someone decides to open up a factory and a city grows around it. Or they realize that there is a location that is perfectly situated near natural resources. It's near a coal field, or it's close to a harbor. Cities grow up around those resources. So now we have all of these people moving from the country into the city. But this creates new problems that these cities haven't had to deal with. And it's not just the new cities, it's also old cities that have to deal with these problems. So some of the impact, I mean, this wasn't something that the government said, okay, over the next 50 years, cities are going to grow. This happens pretty rapidly. One major problem is that cities don't have infrastructure to deal with all of these people. They don't have enough roads. They don't have enough police forces. They don't have sewer systems. They don't have housing. Housing is going to be the first thing that needs to be taken care of, because if your workers don't have a place to have shelter, they won't be able to show up for work the next day. So many factory owners in cities build what we would call really big sort of apartment buildings. They become known as tenements. They house multiple families where we would just think one family might live or a single person might live. They're very, very crowded. And in business, there's this concept that, there's three elements. There's good, cheap, and fast, and you can only have two at a time. The tenements are the perfect example of cheap and fast. It was sort of a temporary solution that ends up being pretty permanent. This is what tenements looked like. Multiple families living together in a city. This is in New York City, but it would have looked like this around the world in industrialized countries. Multiple families living in small areas in a city that doesn't have the roads to equip all of the carts that are now needed, that doesn't have the sewage treatment and the sewers to deal with this many people. This is a pretty famous sketch of what's supposed to be London. In London, they didn't necessarily build up as much, they just build closer together. So the width of one of these houses was maybe the width of half of our classroom. Very crowded. And this crowding creates all sorts of problems in addition to just factories themselves. Burning all of that coal to heat your home, to run steam engines, that creates a lot of smoke. And like London, it's very foggy to begin with. So you have smoke, you have fog, which creates smog. We know now this creates health issues, pollution issues. At the time, they didn't necessarily care. Even if you don't live in a family, you still have to share your space with lots of other people. This leads to the spread of diseases. When you have lots of people living together who don't bathe all that often, you're going to get diseases. Some of the diseases are directly related to new types of jobs. Some are related to the pollution that's taking place. So breathing problems would have been very common, oftentimes from working conditions. For example, coal miners would get something called the black lung, where coal dust starts coating your lungs. Tuberculosis was a very common disease as well that is contagious, could come from air pollution, or possibly if you are working with chemicals in your job. With water pollution, this comes from runoff from factories, but also lack of sewers, and this often led to cholera. Cholera comes from infected water sources, and in essence, it is having diarrhea until you die. Really an unpleasant way to go. But if you are lacking proper sewer systems, that will then spread to other people very, very rapidly. Another thing that changes is the idea of time. Time itself is not new, but the way we understand time as a society changes. Before the Industrial Revolution, time was based on light, on the moon, and on seasons. You plant your crops when it gets warmer. You harvest your crops when it's about to get cooler. You know that it's time to bring in the cows when it gets dark at night. But that's not going to work in a system that uses factories. Workers are paid according to how many hours they work, not when the sun comes up. So it becomes very important that people show up at specific times, not just at certain lights or seasons. This is where we get the idea that time is money, and I know all of you have heard that. Another thing, the trains. If you're a business owner and you're trying to get your products from your town into the big city, the railroads can't just say, we'll be there sometime on Thursday. Your time is valuable now. So railroads create timetables and schedules, specific times when trains will run. So all of these things are elements that are now familiar to us in 2013, and they began about 200 years ago as a result of the Industrial Revolution.